This conference will now be recorded.
Good morning, students. Today I'm going to discuss about the Unit 1. Let me share with you and let me start the session. If you have any doubts, you just give a message in the chat box. Okay. Today I'm going to explain about design and analysis of algorithms, and the main learning objectives of a design and analysis of algorithms is analyze the asymptotic performance of algorithms. First of all, you need to analyze the asymptotic performance. Asymptotic performance means either it might be big O notation, omega notation, or theta notation. You need to analyze by the end of this, after completion of the data, you need to analyze the asymptotic performance of any algorithm and write rigorous correctness proofs for algorithms. You need to write the correct algorithm. It means what is a correct algorithm means without having any errors, what the algorithm you had written will be the correct algorithm. And next, demonstrate a familiarity with the major algorithms and data structures. You need to demonstrate the algorithms by using some data structure concepts like stack, queue, heap, different types of data structures. And next one is apply important algorithmic design paradigms and methods of analysis. Here you are having many types of design paradigms. In this design and analysis of algorithms, you go with the 5 types of design paradigms. They are greedy method, divide and conquer, dynamic programming, backtracking, branch and bound methodologies. You can use any of these design paradigms to solve any problem. Synthesize efficient algorithms in common engineering design situations. Here you need to design an efficient algorithm for the engineering design situations. And coming to the syllabus of the first unit is, first unit consists of what is an algorithm, algorithm specifications, pseudocode conventions, recursive algorithm, performance analysis, space complexity, time complexity, amortized complexity, asymptotic notations, practical complexities, and performance measurements. These are topics which you are going to study in this unit 1. And next, coming to the introduction of the algorithm. What is an algorithm? You all know that from the data structures you have been reading that algorithm is a finite set of steps used to solve a particular problem or task. Here also you'll learn the same thing. An algorithm is a finite sequence of instructions. Here, algorithm will have some specifications. Every algorithm should follow some specific specifications. Here also, I'm telling about those specifications. First one is input. Every algorithm must have 0 or more number of quantities as input that should be supplied externally. It means every algorithm should take at least 0 or more number of inputs, and it has to produce 1 or more number of outputs. It means every algorithm may or may not take the input, but it need to produce the output. Based on the output only, we'll know whether the algorithm is running properly or not. Next one is definiteness. Each instruction must be clear and unambiguous. Here, whenever you write an algorithm, each step of the algorithm should be definiteness. It means there shouldn't be any ambiguity in the step. Suppose if you write 2 by 0, it gives infinity. That leads to the ambiguity. You should not write those type of steps. The algorithm should be in a definiteness. Next one is finiteness. If we trace out the instruction of an algorithm, then all the cases of the algorithm should terminate after a finite number of steps. Whatever the algorithm you write, it should terminate in a finite number of steps. It means you should count the number of steps in the algorithm. The algorithm steps should not be infinite. That leads to the ambiguity. Next, last point is effectiveness. How effective the algorithm step is. It means you need to trace each step by using a paper and pen and a paper. It means every instruction must be sufficiently basic that it can be that it can in principle be carried out by a person using a pen or pencil. It means the step should be in such a way that you can solve by using a pen and paper. It should not give any ambiguity. It should not be very complex. You should write in a simple way. These are the algorithmic specifications. And next one is an algorithm, an example of an algorithm. And here I'm writing an algorithm which is used to add two numbers and display the result. Step 1, start add. Actually, in 10th class also, I think you had gone through these algorithms. Anyways, first step will be the start and last step will be the end of the algorithm. Step 1 is start add, and here you need to add two numbers. It means you need to take, it means you need to scan two numbers. It means get values of A and B. It should be 2 plus 3 is equal to 5, and 5 will be stored in the result. So you need to take two elements either from the keyboard or directly from the algorithm. So get values of A and B, and step 3 is equal to C is equal to A plus B. And the value A plus B is stored in the C, and that should be displayed on the screen. This is a simple algorithm to explain about an algorithm. And next, some general issues that are facing while analyzing the algorithm. What are those general issues is, first one, what data structures to use? Here we use different types of algorithms. What data structure should be used? Here sometimes we use lists, sometimes we use queues, sometimes we use stacks, sometimes we use heaps, and sometimes trees. It means suppose if you are using BFS, we'll use one type of data structure. If you are using DFS, we'll use one type of data structure. So for recursion, we use one type of data structure. So we should be clear that what data structure to be used while generating an algorithm. Is it correct? It means we need to write an algorithm in such a way it should be in a generalized way, because it means in a generalized way means it should be applicable to all types of the all the problems of the same type. It means adding of two numbers. It should add 2 plus 3 or 4 plus 5 also. It should be applicable. It means the algorithm which you write should be applicable to the all problems which are of the same type. It should be generalized. And next one is, how efficient is it? How efficient is it means asymptotically fixed, or does it depend on any inputs? It means algorithm efficiency, asymptotic means asymptotic notations might be big O notation, omega notation, theta notation. These are generally used in the while computing the algorithm time complexity. So efficiency of the algorithm generally depends on the time complexity and space complexity of the algorithm. And sometimes the time complexity always depends on the inputs taken by the algorithm. So how efficient it is, whether it is giving good results or not, whether the algorithm is efficient or not. This can be calculated by using this time complexity and space complexity. Is there an efficient algorithm? How can you say this algorithm is efficient? Is it efficient or not? Suppose if you want to go from one source to destination, there may be many possible paths. Which one is the best path? It depends on the criteria you choose. Sometimes you choose money as a criteria, sometimes you choose speed as a criteria, sometimes you choose good road as a criteria. Based on your requirement, you will choose which algorithm, which way is the best path. Same way here also, we can solve a problem by using different types of algorithm methodologies. You need to choose which one is efficient for your methodology. So here, is there any efficient algorithm? It means suppose we can say which algorithm is the best algorithm. We can write addition of two numbers in many different ways. So based on the time complexity, it means what is time complexity means the time taken for an algorithm to run for a particular period in a computer. It means the time taken by an algorithm to run in a computer. So if one algorithm takes T1, the same algorithm in another system takes T2 time. If T1 is less than T2, then first algorithm is the best algorithm. This is how you need to analyze the algorithms. And next, what are the basic techniques? These are some of the basic techniques which we use in this design and analysis of algorithms. There are basically 5 fundamental techniques which are used to design an algorithm efficiently. First one is divide and conquer methodology, and second one is greedy method, and third one is dynamic programming, and fourth one is backtracking, and fifth one is branch and bound. So let us discuss briefly about these basic techniques so that you will understand what the main theme of this algorithm in the next coming chapters you can analyze. First one is divide and conquer. In divide and conquer, this is basically a top-down approach. What is top-down approach means? We need to solve the problem from the beginning condition, and we need to divide the problem into sub-problems. This is known as top-down approach. That sub-problems will be solved, and will again conquer those sub-problems and give the solution to the large problem. It means dividing the large problem into simple sub-problems. That is nothing but a top-down approach. The algorithm which follows divide and conquer technique involves 3 steps. Here, what are those 3 steps? Means divide the original problem into set of sub-problems. Here we'll take a complex problem and we'll divide that complex problem into some of the set of sub-problems. Next, we conquer. Conquer is nothing but here solve those sub-problems. Here we solve those every sub-problem individually. And we combine all the solutions of the sub-problems and get the solution to the original problem. This is the methodology used in the divide and conquer method. Here some of the problems in this DA, we read some of the problems which follows the basic principle of divide and conquer. Those examples are first one, binary search. In binary search, we'll divide by considering the mid element, we'll divide the list into two subparts. And again, we'll consider the midpoint. Again, we'll divide this list into sub problems where we cannot further divide anymore. Then we'll solve those sub problems and we'll generate the solution to the main problem. Same way, multiplication of 2-bit numbers, quick sort, heap sort, merge sort, all this follows the principle of divide and conquer methodology. Next one is greedy technique. This is the second method which we. What is this greedy technique means? To solve an optimization problem. Here, by using greedy technique, we solve the optimization problem. What is this optimization problem? Optimization problem might be minimization or maximization problem. In some cases, it will be minimum value. In some cases, it will be maximum value. So what is minimum case values? Suppose if we consider a traveling salesperson or else a traveling salesperson, if you consider a traveling salesperson, here you need to travel all the nodes by having with the minimum cost. Here the optimization is minimum value. So minimum value means here traveling salesperson means you'll have a graph containing many nodes. You need to rotate all the you need to pass through all the nodes exactly once, and you need to reach the starting node with minimum cost. That will be the minimal problem. What is maximization problem? In 0-1 knapsack, you need to attain the maximum profit. Suppose, for example, if you run a shop or some grocery shop, what is your main goal? To attain the maximum profit. That is known as optimal profit. Suppose if you want to go some place, if you want to visit some place, you need to visit all the tourist spots in the places with the minimal cost. So while visiting the tourist places, you consider it as a minimum path as the minimum cost as the optimal value. While running grocery shop, you will take maximum profit as the optimal value. In some problems, you will have the minimum value as the optimal solution, and in some problems, you will consider maximum value as the optimal solution. The greedy technique will have a many, this is the optimal solution. Depends on the problem, you need to choose whether it is minimum value or it will be maximum value. An optimization problem is one in which we are given a set of input values, which are required to be either maximized or minimized. Suppose by taking some input values, we'll solve the objective function and we'll get the minimum value or maximum value. That should be the optimal to that particular problem. Locally optimal choice in the hope that this choice will lead to the overall globally optimal solution. Because here we'll divide the problem into sub-problems. Here local optimal choice. For that sub-problem, the local optimal value will be considered. By combining all those local optimal values, we'll obtain the global optimal solution. And it does not always generate the guaranteed the optimal solution. In greedy method, we can't guarantee that will be the optimal solution, because generally it produces an optimal solution that will be sometimes close to the that will be an optimal solution or sometimes close to the optimal solution. And the examples which use this greedy method are knapsack problem, and we'll discuss this in the third unit. Second unit will study the greedy method, and second unit will study the divide and conquer. Third unit will study the greedy method. Fourth unit will study the dynamic programming, and fifth unit will study the backtracking. And in sixth unit, we'll go with the branch and bound. So all the methods which we had written here as examples will be solving in those while reading the techniques in the unit wise. So the main examples of this greedy approach are knapsack problem, minimum cost spanning tree. In the minimum cost in knapsack problem, maximum value, maximum profit will be the optimal solution. Here in minimum cost spanning tree, we need to reach the entire tree nodes with the minimum cost value. By using some Kruskal's algorithm and Prim's algorithm, you'll solve this. Here the optimal solution is minimum cost. Single source shortest path, Dijkstra's algorithm. These are some of the examples which is greedy method. Next methodology is dynamic programming. Here, the dynamic programming is a bottom-up approach. See, divide and conquer is a top-down approach, whereas dynamic programming is a bottom-up approach. Bottom-up approach that begins by solving the smaller subproblems. First, we need to solve these subproblems and we'll combine those subproblems and we'll attain the solution of the main problem. That is the technique here we use in the dynamic programming. The dynamic programming approach always gives a guarantee to get an optimal solution. Here in greedy method, we said that the optimal solution, it may not attain the optimal solution. It will be sometimes it may attain the optimal solution, sometimes it will be close to the optimal solution. Whereas in dynamic programming, obviously will guarantee the optimal solution. So sometimes greedy approach is the best method for some problems, and sometimes dynamic programming will give the best results for some problems. The main examples of this dynamic programming are all pairs shortest path by using Floyd's algorithm, chain matrix multiplication, longest common subsequence, 0-1 knapsack. Here also we'll read the 0-1 knapsack. In a greedy approach, that is known as fractional knapsack problem. In dynamic programming, we call it that knapsack problem as 0-1 knapsack problem. And next one is traveling salesperson. And next approach we study is backtrack algorithms. Backtracking algorithms try each possibility until they find the right solution. Suppose it's just like a puzzles which we solve in our childhood. In puzzles, we'll see that we need to reach from one position to the another corner of the problem. So we'll go in one path. If we think that we don't give the solution to the problem, then we backtrack. It means we'll come back and we'll move to the another way and until we reach the solution. Here, that same methodology is applied in the backtracking methodology also. What is suppose if you want. You think that in some state that you'll think that by passing through this street you'll attain the shortest path. After going some path, you'll see that that street has a dead end. Then you'll come back to the main street. That is known as backtracking. It means you'll go in one path. If you think that it won't give the solution, then you come back to the previous stage and we'll move forward. That methodology is known as backtracking methodology. Here, backtrack algorithms try each possibility until they find the right one. When the alternatives are exhausted, it means there are no more ways to reach the solution. Then we'll go to the previous choice. Then the search returns to the previous choice point and try the next alternative path. We'll go to the next path and we'll find whether we are going to obtain the solution or not. If the solution is going to obtain, we'll move in this path. If I think that a solution cannot be obtained by moving through this path, we will backtrack to the previous stage and we'll move to the next alternative choice. If there are no more choice paths, the search fails. Obviously, if there are no more choices and we haven't obtained the solution, then we'll fail in obtaining the solution. It means there are no solution to that problem. The main examples which we study in this backtracking methodology are N-Queen's problem and some of the subsets. And a branch and bound methodology, general optimization technique that applies where the greedy method and dynamic programming fails. Here, the branch and bound is similar to the one of the techniques in the algorithm. Here, it also uses many techniques which we are used in the greedy method and dynamic programming. But here, the main advantage of using branch and bound is where the greedy method and dynamic programming fails, that problems can be solved by using branch and bound methodology. Branch and bound is the most widely used tool for solving large-scale NP-hard combinatorial optimization problems. For this type of problems, we use this branch and bound. What is this branch and bound means? It is similar to the backtracking. In backtracking, we'll come to the one of the branch. If we think that we can't attain the solution in this branch, we'll go back to the previous state. Same wise, some branch and bound means we will come to the one path based on some conditions. We'll take some conditions. And if the node fails to attain those conditions, then we'll think that we can't attain the solution through this path and we'll go to the next branch. This is how we find out the solutions in the branch and bound methodology. The main examples which we study in this branch and bound are assignment problem, traveling salesperson, and one more is 0-1 knapsack problem. In traveling sales problem can be solved by using two methodologies, static traveling salesperson and dynamic traveling salesperson. And 0-1 knapsack also we can obtain 0-1 knapsack already we had seen in greedy method, that is fractional knapsack problem. And next dynamic programming also will solve this knapsack problem by using 0-1 knapsack, and branch and bound also will solve the same knapsack problem. Here, the knapsack problem is solved in two ways, that is LCBB and FIFO-BB. It means least cost branch and bound and first in, first out branch and bound. We obtain the zero knapsack problem efficient solutions in this branch and bound, where dynamic programming and greedy knapsack fails. So next, coming to the students, do you have any doubts till these topics? Give me a message in the chat box. Okay, thank you so much. Okay, analysis and complexity of algorithms. What is meant by analysis, and how you find out the complexity of an algorithm? How you analyze this algorithm is the best algorithm. So analysis of algorithm is the determination of the amount of time and space resources required to execute it. It means whenever you say this algorithm is the best algorithm, how you will say it means you need to find out the time complexity and space complexity of an algorithm. What is this time complexity? What is the space complexity means? If the algorithm run on a system, how much time the algorithm take to run in a particular system? The time tells about the time complexity. If to run a algorithm, how much space it is required to run that particular algorithm, that is known as space or memory requisition of an algorithm. So time complexity deals about the time of an algorithm, and space complexity deals about the space or memory occupied by an algorithm. So based on this, which algorithm takes the less time and less space, that algorithm is considered as the best algorithm. So this is how we analyze the complexity of an algorithm. Here, generally we perform the following types of analysis. These are some of the analysis which we analyze the time complexity or space complexity of an algorithm. First one is worst case. What is this worst case? The maximum number of steps taken on any instance of size n. Suppose I want to give a simple example for this. Suppose if you want to go from source to destination, if you want to move from a source, suppose source might be your house and destination might be some bus stand. So how much time you require to reach the bus stand? If someone asks how much time I need to go to bus stand, then you will say it may take from 20 to 30 minutes. Why you are saying that it's not exactly 20 or 30? It means you are taking roughly from 20 to 30. It means depending on the person capability. If he is an old person, he'll go by 30 minutes. If he is a young person, he'll reach the bus stand in 20 minutes. Same wise, algorithm also takes some algorithm also takes some performance to run the system also takes some performance to run that algorithm. In worst case means this is the upper bound required for the algorithm to run. For suppose if you want to it also sometimes depend on the size of the input taken. Suppose the maximum number of steps taken on any instance. It means if we take for loop for I is equal to 1 to n do. Suppose I is equal to 1 to n do means I is equal to 1 to you need to take 10 number of steps. If n is equal to 20, you need to rotate 20 number of times. If n is equal to 100, the algorithm need to run 100 number of times. It means time will be increasing as the input size increases. So worst case means whenever an algorithm takes maximum time, it means maximum time to reach to execute that program, that is known as worst case. Best case means the minimum number of steps to get the output, that is known as best case. Average case means averaging the worst case and best case will get the average case. What is this amortized means? We'll take some sequence number of operations. We'll give some inputs. So first time we'll give for fun loop we'll give as 2, and next time we'll take 3. Next time we'll give 10. Next time 20. We'll take some number of sequence of operations and we'll average all those operations and give the solution for one single number of step. It means averaging all the sequence of operations and giving for us for one number of step is known as amortized analysis. Can you understand what I'm saying? So listen, what is worst case means maximum number of steps. I can give an example. Suppose if you want to run an algorithm, it means linear search. Linear search means you need to find a pivot element whether it is there in the list or not. Suppose the list contains elements some even numbers till 20, 2, 4, 6, 8, some 20. So first of all, if you want to find out the element 2, whether 2 is present in the list or not by using some linear search. Then you'll check first time 2 will be there in the 2 is the first item in the list. So the minimum number of steps required to obtain 2 is only 1. That is the best case. If you want to find out the 20, if you want to find out 20 means in linear search, first you need to check 2. 2 is equal to 20 or not? No. Again you will move to 4. 4 is equal to 20 or not? Again you will move to 6, 8, 10, 12. So you need to check all the elements until the last element 20 is found. That is known as worst case. It takes maximum number of steps. That is known as worst case. What is this average case? Average case means it is the average of, in best case we obtain in the first step, in the worst case we obtain the nth step, n plus 1 by 2. That is equal to, that gives the average case. Amortized analysis. Amortized analysis means, suppose if you want to find 2, then the number of steps required is 1. If you want to find 4, the number of steps required is 2. If you want to find 6, the number of steps required is 3. So averaging all this 1 plus 2 plus 3, how many times you take? If you perform this operation 5 number of times, then you need to take the first 1, 2, 3, 4, 5 divided by 5. That's gives the amortized analysis of an algorithm. So let us see by using an example, linear search. Here, linear search means, what is the input? A linear list A with n elements and searching element X. It means you need to consider a linear list, list having a name A and it is having n elements. You need to find an element X, whether X is present in the list or not. So output means finds the location of the X in the array A, and to indicate X is not, if X is not present in the list, you need to specify LOC is equal to 0. It specifies that X is not. Suppose initialization. How you initialize? Initialize means set k is equal to 1. Set k is equal to 1 means first element in the list, location is equal to 0. First you'll think that element is not found, so you'll start from 0. Repeat steps 3 and 4 while location is equal to 0 and k is less than or equal to n. So you need to increment the k value to 1 by 1, 1, 2, 3, and you need to check whether the element is found in the list or not. If the element is found in the list, then LOC becomes 1. If the element is not there in the list, LOC becomes 0. So X is equal to A of K. You'll check first element whether it is equal to X or not, what the pivot element or not. If it is the pivot element, then you can return that X is the pivot element. You'll return element is found in the list. If element is not there in the list, then what you'll do? You'll increment K value. Again, you'll check whether the K value is equal with the pivot element. You need to perform till the element is found. If until the last element you didn't find the element X is then X is not there in the list. You need to specify LOC is equal to 0. X is not present in the list. If you found the element anywhere in the list, then you return the LOC value and X is present in the list. This is how you need to specify the linear search. If the you all know this linear search, you had studied in the data structures only. So I'm just explaining what this linear search is. Here I want to analyze, here I don't want to explain the algorithm. I want to explain about the analysis of the algorithm. So what is the best case, average case and worst case by using this linear search? If the element is found in the first case, see, if the element is found in the first case, that is known as a best case. If the last element is the element which we want to, which is the pivot element, then that is known as worst case. If the element is found in between best and worst case, that is nothing but the average case. So see, analysis of linear search algorithm. The complexities of such algorithm is given by the number of C. It means the complexity is defined as the based on the C, and the C tells about the number of comparisons done with X. X and K is the element moving from a starting to ending node. So how many number of steps you have taken to find the pivot element? So in best case, A of K is equal to X. It means first element comparison is equal to 1. If you found the first element as the pivot element, then you will obtain the first element. That gives the best case. What is this worst case? Worst case means when the X is the last element, you need to search all the elements. If X is equal to 20, you need to search all the 19 elements. You need to reach the 20th element. So you need to find all the 19 elements. You need to so I have to obtain the 20th element. So this is known as worst case. So clearly the worst case occurs when the element is the last element which you need to find out. Then that is known as worst case. Sometimes you will not find the element, that also will become the worst case. Anyways, if the element is not in the list also, you need to search all the elements, whether the element is found in the last position or whether the element is not there in the list. That will become the worst case. What is the average case? Average case means we need to average all the elements. It means generally I'm saying best case plus worst case divided by 2 becomes the average case. Here best case is equal to 1, worst case is equal to n. 1 plus n divided by 2 becomes the average case. What here we assume that search element x appears appear in the array A, and it is equally likely to occur in any position between the best and worst case. It may be in any position 1 to 2 to some n minus 1. It can be in any position. So it is the average case. Average is nothing but the name itself indicates it's the average. It is the average of best and the worst case. And next, pseudocode. What is a pseudocode? Pseudocode means it is just like a machine code, but it is not completely machine code, but it can be easily understandable by human. It means what is algorithm means? Algorithm is an English like representation, whereas pseudocode will be just like English, but it will be a semi-machine language. Pseudocode is a notation system for writing algorithms, which is used for writing algorithms. The pseudocode notation specifies operations that a machine can perform in as human friendly, which can be easily read by the human, as well as it will be in a machine like a language, so that we can avoid ambiguity. So what are some of these pseudo conventions? Because the algorithms, everything will be written in the pseudo convention. So you need to know what these conventions, how the conventions will be in the conventions to write an algorithm. So the following conventions must be used to present your pseudocode. So some of the conventions are represented here, and we'll see one by one. Give a valid name for the pseudocode procedure. It means if you start an algorithm, just write algorithm sum. That sum, a name should be given, valid name should be given to the pseudocode procedure. Here we won't specify the algorithm. I'll write procedure sum. That will be the convention in the pseudocode. Next one, use the line number for each line of the code. For every notation for every line, you need to specify 1, 2, 3, 4. Number of lines should be indicated while writing a pseudocode. And third one, use proper indentation for every statement in a block structure. See, indentation plays major role in Python also. If you don't give the correct indentation, it gives us syntax errors. So indentation should be followed in this pseudo conventions also. Indentation means, suppose if a statement is started, then end if also should be in the same line. That is the indentation. Use proper indentation. That should be used properly, so that where the if loop is started and where the if loop is ended, where the while loop is started, where the while loop is ended, that will be known easily. For a flow control statements, use if else. Always end an if statement with the end if. Suppose if you want to use if else, then if is completed, then you need to specify end if. Both if else and end if should be aligned vertically in the same line. If suppose you want to write a statement if condition, if the condition is true, you need to execute some statement, else you need to execute some other statements. After completion of if and else, you need to specify end if. All the if, else and end if should be in a same line, so that one condition, you'll understand this is the same condition. When you won't get confused and system also won't get confused. See here, I had given one example, if condition expression statements. See the indentation. If else are in the same indentation, else statements. Next, and if condition, we started the if condition and we ended the if. This is the fourth point. Fifth point, for assignment operator, suppose a is equal to 5, that will be specified by using equal to symbol. And in pseudo convention, we should not use that equal to symbol. For specifying the assignment statements, you need to use backward arrow symbol. So if I is equal to, see the example, I is equal to j, then you need to specify I with the backward arrow. That indicates the assignment operator. Don't get confused. Just for equal to, instead of using assigning symbol equal to, we use a backward arrow symbol. Sixth point, array elements can be represented by specifying the array name followed by index in a square brackets. Here the array means, suppose here while using arrays, we need to specify one square bracket, and I value should be, if you want to use 10 elements, then specify a square brackets 10. That indicates you can use 10 elements in the array. And next, while specifying for loops also you can use for loops or while loops. Everything will be used with the for loop. For loop or while loop, you need to indicate the end of the loop by using end for end while loops. That will be the seventh statement. And eighth one, the conditional expression for or while can be written as. So the condition C here in as shown in the fourth rule 4. If condition expression, same as if it is while means while condition expression. If it is for condition expression, for I is equal to 1 to n do. You need to specify do in this pseudo conventional code. Let us see this example. Here one small mistake is there. Can you identify? Give me a message in the chat box. Can you identify the mistake? No. Yes, that is the mistake. Here we haven't specified the line number. Here, second condition, what we had written, use the line numbers for each line of the code. But we haven't mentioned the line numbers. So that is the mistake. In pseudo conventions, you need to specify the line numbers. First condition, see whether the condition following or not. First condition, give the valid name for the pseudocode procedure. So see here we had given a valid name, insertion sort, and we are considering an array array with a list. Array indicates a list of elements. For j2 length of a, j2 length of a means j is equal to assigning 2 value to the j, key is equal to a of j, and I is equal to j minus 1. So here unfortunately 3 is printed. So insertion sort means we'll be comparing I and j values, and if I value is less than j value, then j will be incremented. Again it will be compared with the second value. Same way, if the elements will compare the side by side elements, we'll swap those elements. This is how the insertion sort works. This is the pseudo convention code which we had used for this insertion sort. And next one, what is recursive algorithm? You all know that I think you had gone through this recursive algorithm in data structures also. Here also I'm giving a brief introduction regarding the recursive algorithm, because these recursive algorithms are maximum used in the recurrence relations, which is used to find the time complexity of an algorithm. So here I'm specifying what is recursive algorithm. The recurrence relations often arise in calculating the time and space complexity of an algorithm. So while specifying the time and space complexity, we use this recurrence relations. So recurrence relations use the recursive property. So we are so that's why we are learning recursive algorithm in this topic, in this unit. Any problem can be solved either by writing recursive algorithm or by writing non-recursive algorithm. Every problem can be non-recursive means it's nothing but iterative method. Every problem which we are doing right now, we can be solved by using recursive method or iterative method. So recursive algorithm is one which makes a recursive call to itself. Self-call is nothing but a recursive algorithm. We often use a recurrence relation to describe the running time of recursive algorithm. We have a bigger problem. How we use this? If we have a bigger problem, suppose where the recurrence relation is used means we can use this recurrence relation in Fibonacci series and factorial problems that can be solved by using this recurrence relation. I'll tell you how we'll solve. First of all, here, if we consider a bigger problem whose solution is difficult to find, then we divide that big problem into small subset of problems. And that small subset of problems should be able to solve the big problem. By calling that recursively, we need to solve the problem, keeping on decomposing until we reach the smallest subproblem. We need to decompose till the smallest subproblem is found. To go back in a reverse order and build upon the solutions of the subproblems. We'll see by using by writing an algorithm for factorial, we'll see how the recursive algorithm is obtained. Recursion is applied when the solution of the problem depends on the solutions to smaller instances of the small problem. See, for example, If you write if you want to write a program for factorial, int factorial int n, if n is equal to 0, this should be the base case. What is base case means? I'll tell you. So n is equal to 0, that is the base case. Then return 1. Else, general recursive case. This is else. You need to write the recursive case. What that is? Return n into factorial of n minus 1. This factorial of n minus 1 should call again this factorial of n. By calling recursively, you will obtain this recursive function. Here, a case for which the answer is known. A case for which the answer is known as the base case. It means n is equal to 0. We know the answer. But for a factorial of n minus 1, we don't know the answer. So what the answer is known, that will become the base case. Each recursive algorithm must have at least one base case as well as the general recursive case. One base case should be known. So that base case gives a solution to the entire problem. So we'll see how the solution is obtained. See, recursion versus iterative method. The factorial of a positive integer n denoted by n factorial is defined as a product of the integers from 1 to n. Here 4 factorial means how we'll write 4 into 3 into 2 into 1, that is equal to 24. In iterative method, n factorial is equal to, if is equal to 0, n is equal to 0 means 0 factorial is equal to 1. If n is greater than 1, then how? How means n minus n into n minus 1 into n minus 2. See here 4 factorial means n into n minus 1 into n minus 2 into so on till you obtain last element to 1. This is how you write the factorial of a number. In recursive method, what you will do? Factorial of n is equal to 1 when n is equal to 0. Here, suppose n into, how we write means, I'll explain you. Here, n into fact of n minus 1. Again, what you will do? n into n minus 1 into fact of n minus 2. Same way, fill n into n minus 1 into n minus 2 into so on till you get fact of a 0. Fact of 0. Then how the solution is solved? See, control C. Fact of 0, we know that is 1. So by using this, if we have this base case, then we can easily obtain the solution for the general case. This is how you need to find out the recursion of a factorial algorithm. So here till we get n is n minus 1, n minus 2, so on, factorial of 0. N is equal to 0. When we get a factorial of n is equal to 0, then we know the solution is 1. So by placing n into n minus 1 into n minus 2 into so on 1, we'll obtain the same iterative method. But here the function calls itself, that is known as a recursive function. And 3 questions verification method. While doing this recursive method, we need to verify 3 questions. The first case is the base case question, whether the recursive function having base case or not. Is there a non-recursive way out of the function? It means we need to get out of this recursive function. How we'll get out of this recursive function means fact of 0. Fact of 0 will have the base case. You will have the value, numerical value for this base case. Then only we'll get out of this recursive function. So whether is there that possibility or not, you need to verify that. Does the routine works correctly? Base case. That means if n is equal to 0, return 1. That is the base case. It means that the base case, we use the base case to get out of this recursive function. So we use this base case question, whether it is there or not. This is the first question we need to verify. Second question, the smaller caller function. It means does each recursive call to the function involve a smaller case of the original problem? It means leading towards a base case. It means whether we are reducing the function or not. Suppose n minus 2, next step it will be n minus 3, next n minus 4, n minus 5, so on n minus n. Whether it is reducing or not and leading to base case or not, we need to verify. That should be the second case. We need to verify that smaller caller function. Next, the general case question, assuming that recursive calls work correctly, does the whole function works correctly? It means a general case question is general factorial. Whether the function working correctly or not, we need to specify. Based on these three questions, we'll know that the recursive algorithm works correctly. And next, coming to the asymptotic notations, we'll see these asymptotic notations in the next class, because it has been 45 minutes. So let me stop here, because asymptotic notations will not end in 5 minutes. It may take nearly half an hour or half an hour to one class completely to know this asymptotic notations. We'll see in the next class. Do you have any doubts regarding this pseudo conventions or recursive algorithms, or any of these algorithm specifications, algorithms? You can ask. Just ping me in the chat box so that I'll understand whether you have doubts or not. In backtracking, is there any more examples? Yeah, in backtracking here I had written n queens problem and some of the subsets. And we can solve m coloring problem also by using this backtracking. There are many more methods, many more examples in each technique, but I have taken only few of them. Okay. Thank you. Thank you so much.